Hello friends and neighbors, I'm going to show you how to compute a one sample proportion test in R, and also a confidence interval. First you double click on R and you load library R commander EZR. Mine is automatically doing it, but here's what the instruction looks like. Library R commander. You hit enter and it pulls up this window. You go Tools, Load R Commander Plugins, choose EZR, and click OK, and you click Yes. Now that R Commander and EZR are open, I can File, Import Data, Read Text Data. All the data files we have are text, CSV. The one I'm going to do is Kids Choice. It's one of the teams from spring 2017. Click OK. You'll find it. Kids Choice. It's the data file. It's CSV format. Click Open. They have a categorical variable, and they want to know what proportion of the population gives their kids a flu vaccine. Go to Statistical Analysis. That is a categorical variable, so it is discrete. Statistical Analysis, discrete variables, one sample proportion test. Choose the variable, which is vaccinate. Now choose chi-square test, exact test, and turn off the continuity correction. At this point, we select their hypothesis, which I don't know what it is. Let's say it's a two-tailed test, which is the default. And let's say they hypothesize that, I don't know, 40%. I'm changing it from 0.5 to 0.4. 40% of the population gets their kids the flu shot. And then, for confidence level, I'll set it at 0.95 for a 95% confidence interval. And then, here's the hard part, you click OK. And that's it. Here's your sample proportion. It's p hat equals 0.47. Here's your 95% confidence interval. We are 95% confident that the population proportion is somewhere between 0.3 and 0.64. And here's your hypothesis test. It gives you a p-value of 0.46, which tells me I do not reject the null hypothesis. That means that I believe that in the population, 0.4, 40%, is a reasonable conclusion. So I believe, with what I've seen, that 40% of the population gets their kids the flu shot. One last thing, the test statistic that it reports is a chi-square, but in the OpenStax textbook, we used a z-test. It's the same thing. If you computed the z-test and squared it, it would give you a chi-square. It's exactly the same thing. It's a chi-square with 1 degree of freedom. That is the same thing as a squared z-score. And that's it. You put this stuff in your paper and go to town.